And we are recording. All right. So 3A. So it's entitled Uses and Abuses of get this in a second. Percentages. And in terms of abuses, I'm not going to make a whole lot about it right now. We'll talk towards the end. I always look at, especially advertisements or politics, particularly politicians. This isn't I'm not going Democrat or Republican on this deal. Not going that way at all. I always just tell people, be aware, everybody's trying to sell you something. And so the biggest thing is just to be educated in how, in this case, percentages work. So that if somebody is trying to make the numbers appear to be something they're actually not, they're not, because you're educated about how the numbers work. And that is my goal here. So, and so we're just going to basically talk about percentages in and of themselves. Let me want to here. All right, so here we go. So first off, 3 ways you'll see percentages used. One, express a fraction of something. All right. So, as an example, and this is coming straight out of the book, but a total of 13,000 newspaper employees, 2.6% of those newspaper workforce lost their jobs. So a particular fraction of that workforce, used to describe a fraction of that workforce in that particular case. So, but that is one way percentages can be used to express a fraction of something. 2, to describe a change in something. So, again, just an example from the book. Company stock fell 15% last week to $44.25. But the value of that stock changed, and we're expressing that change as a percentage. So, second way we can use percentages. 3 is comparison. So percentages can be used to compare 2 things. So, example, advanced battery lasts 125% longer than the standard one, but costs 200% more. So again, using percentages to compare, but those are the three things, three ways we can use percentages. So express as a fraction of something, to describe a change in something, or three, used to compare two things. All right. Good, turn the page.
Yes.
All right. I can always turn back. All right. So now we want to define what we call absolute. So we want to talk about absolute and relative change. So absolute change. So two things. We got absolute change. So absolute change describes the actual increase or decrease from one value we'll call the reference value to a new value. So the absolute change describes the actual increase or decrease from one value to a new value. So we'll call that one value a reference value, kind of our beginning point. Reference value to a new value. And we can define it as an equation as absolute value equals your new value minus your reference value. Now, so that means this number could be positive, it could be negative. It just depends on whether that new value is what, less or greater than the reference value. But so it can be negative, it can be positive, it could be zero, there could be no change whatsoever. But you always go new value minus reference value in terms of that absolute value. All right, so now the relative change. So this. The relative change is the size of the absolute change. In comparison to that reference value. And almost always is, but I'm going to write and is expressed Let's write it another way. And can be expressed as a percentage.
So can that also be a negative number as well?
Yes,
Okay.
absolutely. Yes. Great question. And here's why. So we'll have an equation just like we did for absolute value.
Mm-hmm.
So relative change, we will define as a fraction where the top, the numerator, is new value minus the reference value. Divided by the reference value. All right, so they throw this in here, and then we're gonna put this little extra thing times 100%. This part right here,
Mm-hmm.
move the decimal place twice to turn it to a percentage. And you have seen that, so before, that's all that part is meaning, is just turn it to a percentage. So another way to express this is then what is relative change? It is the absolute change divided by the reference value, what your beginning value is. So yes, that percentage that you end up with as your relative change can be negative. So if your absolute value is negative, then your relative change will be negative. And
Okay.
so it really is just a way to kind of describe again what that absolute change is. Okay. So let's look at an example. All right, can I turn the page? Just let me know. I read a lot there. Okay. Casey, Aiden, you okay?
Yeah, I'm good.
All right. So let's look at an example. Stock prices. All right, so try to not write all this, but it'd say during a 6-month period, you had a stock double in price from $7 to $14. So we got a 6-month period. Stock of a certain company doubles in size from $7 to $14. And so basically what I'm going to ask here is what is the absolute and relative changes to the stock price? Just went over. So your absolute change I'm going to abbreviate there. And so remember, it's always new value minus reference value. So you started at $7 and increased to $14. So your reference value is 7. Your new value is 14. So your absolute change is just as simple. $14 minus $7, which is $7. All right, so that is my absolute change, $7. The relative change then, that, then would be $14. Again, that absolute change is what goes on the top. And this is the part to remember, always divide by the reference value. So in that case, that would be $7. Now, if you go just do that calculation right there, you're going to end up with $7 over $7, which is what? 1. Now, so I'm not going to write times 100%. I'm going to put a little arrow. How do we change a number to a percentage? Move the decimal place, what? To the right, 2 places. And that says the relative change was, in fact, what? 100%. And so kind of you catch that in terms of the verbiage. You know, when I wrote this initial statement, I said it doubled its size from 7 to 14. Another way to think of it, though, its relative change was 100%. It you know, 7, if you started at $7, that's 100%. So we basically added on a whole nother 100%. Does that make sense?
Yes.
Okay, awesome. Okay. Now we may be doing comparisons. Calculations are actually, so if we're looking at percentages in terms of comparing two things, you're going to have your reference value and you're going to have your comparing value. So if you're doing that, if you're looking at this in terms of comparisons, then we're going to call it absolute difference. An absolute difference will be compared value right there, minus your reference value. Note the calculation is actually the same as if we were looking at absolute change. Instead of calling it new minus reference, we're calling it compared value minus reference value. And your relative difference, instead of relative change, again, we're looking at calling it relative difference. Then will be your compared value minus your reference value. All right. Divided by always your reference value. And again, we tack on this times 100. That is just saying turn it to a percentage. Okay. So let's look at an example talking about comparing. Turn the page unless somebody objects. So example. Going to look at income comparisons. All right, so some data. California, not surprising, ranked first among the 50 states in average income. And well, it's all I always talk about is cost of living. So I watch some of these home buyer shows or whatnot, or property buying shows, and they're talking numbers like, oh yeah, $800,000. I can't even imagine. But again, they probably make a lot more money out there. But the average in California, the average income in California is $68,400. $900. Well, I hate to say this, but I'll give you guys one guess. What state you think ranks last in average income?
West Virginia.
Ding, ding, ding. You win, Kylie. Yes, it is true. Average income in West Virginia is it's at 46,600. Right. So these are just statistics. All right, but we at least as the time that this problem was put together, maybe we've come, but we're definitely at the bottom, But again, I always think it's relative because our cost of living here actually is less than like if you go. I have friends that live over in Virginia, in the Lake Anna area, and it's a different cost of living. So I guess in that sense it is relative. But all right, we are last at 46,600. So, 2 questions. How much lower is the income in West Virginia than California? That is what we call absolute difference. And then how much higher is average income in California and then in West Virginia? And so we will basically kind of tackle this first question. How much lower is the average income in West Virginia than in California? So if we look at just first the absolute difference, again, all we're going to do. Now, again, how am I phrasing this question? How much lower is the income in West Virginia than in California? Right. So how much lower is that income in West Virginia than in California? So our reference value is going to be California. Our comparing value, because we're comparing what West Virginia to California, that would be our compared value. So compared value is that 46,600 minus the 68,900 in California. And so we come in at a whopping negative $22,300. Now the relative difference and so remember when we do relative difference or we're just talking relative change, it's always going to be that compared value or your new value minus the reference value or that absolute change or absolute difference. So I'm just going to go ahead and say, well, all right, negative 22,300, but you divide it by the reference value, which was 68,900. Now, that actually comes out to be negative 0.324. Then if I turn this to a percentage, that's where I can say negative what, 32 point, move that decimal place 2 places to the right, negative 32.4%. So you actually don't need to do, I mean, you can, just say, okay, it's, move the decimal place in your head twice and get the percentage. But we are 32.4% lower than what California's average income is. All right. Now that answers the first question in terms of how much lower is the average income in West Virginia than California. Now, so can I say that's A. Now we're going to turn it around. And we're going to say how much higher is the average income in California than in West Virginia. And the thing to take about this problem is there is a difference in those two questions. How much lower and then in how much higher. So how much, so I'm going to put, just for reference here, the question on this first part, how much lower was West Virginia than California? This time we're asking how much higher is California. We're turning the question around than West Virginia. All right, so again, we'll figure up absolute difference. All right. So this particular time, since we're saying how much higher is California than West Virginia, our reference value is now West Virginia. Our comparing value we're comparing is the California average income, which was the 68,900, minus then West Virginia's average income, which was 46,600. All right, so that comes out to 22,300, which we would have expected. It would just be the positive, since all we've done is reverse the two numbers. Now let's look at the relative difference. It's going to be our percentage. So that's going to be your absolute difference, which was positive 22,300, divided by your reference value, which this time is that West Virginia average income, which was 46,600. All right, so this is going to come out to be 0.479, which as a percentage is 47.9%. So there's something to take out of that in terms of when we talk about the percentage less or more, depending on how you're comparing them. In the case of saying how much lower was West Virginia than California, we could say, well, West Virginia's out income was 32.4% lower than California's. And that was because we have that negative. But if I ask how much higher is California than West Virginia, it's what, 47.9% higher. And it really what it comes down to is because of the reference value we're dividing by is different in the two cases. All right, are we good with that?
Yeah.
All right. Okay. All right, unless there's an objection, I'm turning the page. And we're going to look at some verbiage about percentages, at least of so. I'm going to use quotation marks to kind of versus more than. All right. So depending on how the question is asked about comparing, we're going to get two different answers looking at the same exact problem situation. So probably the first best way to kind of describe the difference between of and more than is to set up an example. So let's say a population triples in size from 200 to 600. So there are two equivalent ways. There are two equivalent ways to state this change with percentages. One of them is going to be of, one of them is going to be more than. And so we're actually at two different numbers, though again, they're equivalent ways because we're, the change is the change from 200 to 600. So let's say one way. There's going to be two equivalent ways to state this change. Let's talk about the relative change. All right, so the relative change, remember, was new value minus reference value divided by reference value. So my new value is 600. My reference value, where my population started, was 200, and we always divide by the reference number, then turn it to a percentage. So this time I'm just going to say times 100%. You're going to get 0.2 out of that answer. Turning that 0.2, or excuse me, you're going to get 2 out of that answer because you're going to get 400 divided by 200. You're going to get 2. And turning that to a percentage, you're going to get 200%. That's your relative change. So what we're saying here is the new population is 200%. And again, I'm putting them in quotations just to emphasize them. More than 200% more than the original population. All right. Now, another way we could use percentages to describe this change is just to do this. Write a ratio. Your new population divided by your original population. Now for us, that would be 600 divided by 200, which is going to give you 3. I'm going to say 3.00 because if we turn it to a percentage, move the decimal place twice, and that gives me what? 300%, right? All right. Now in words, the new population is 300% of, and I'm putting in quotations just to emphasize what that word is, of the original population. Okay, and so when you hear that word of, when you're saying the word of, you know you're going to be describing a ratio, and it's just going to be the new divided by your original. When you're talking more than, you're talking about a relative. Now, incidentally, that more than could also be less than. And that would just mean that what? Your relative change came out negative because your absolute value change came out to be negative. But notice the numbers were a little bit different there. 200% in the case of the relative change, but 300% new population is 300% of the original. Okay, so now they are related in these particular statements by the fact that what 100% plus 200% is what 300%. That is, if I added 100% to this, that got me to this. All right. Which kind of takes us to the next thing. So if there's no objections, I'll turn the page. So all right, now again, remember the more than could also be less than in case it came out negative. But if the new value was depending on what we're talking about, so new or compared value is, and I'm just going to say P%, 100%, 120%, 200%, whatever, more than the reference value. It is 100 plus P %, and this is the connection of the reference value. Every time. Okay, so if you know you are such and such percentage more than the reference value or the original value, then you could also just basically take whatever that percentage is, add 100 to it, and then you could express it of that compared value is this percentage of the original or reference value. And so then we could also basically state this whole thing again. If the new or compared value is P% less than the reference value, then it is, and as you might expect, 100 minus whatever that percentage was, of the reference value. All right. Uh, you will sometimes be watching the news and hear references about percentage points. So percentage points versus percentages or percent. So when you hear about percentage points, right, a change or difference expressed in percentage points, you're talking about an absolute change. You're just subtracting, you've got 7%, you've got 3%. So that's a 4 percentage point difference between the two. And so that's how we express it. Right? But if that is expressed with a percentage sign, the word percent, then you're talking about a relative change or difference. So let's see here. As an example, so let's suppose a bank increases the mortgage interest rate from 3% to 4%. All right, so we're going to increase our mortgage interest rate from 3% to 4%. So it's tempting to say that you increased your interest rate 1%, but that's kind of ambiguous. So we can say it increased by 1 percentage point. Notice there's no percentage sign symbol in front of this. We're just saying it increased by 1 percentage point.
Is there a reason behind that, I guess?
So you're just in case if you're again, it's just understanding how people are talking about something. So
Okay.
if they say, hey, we increased this by 1 percentage point,
Mhm.
then that is an absolute, you went, when they say they increased by 1 percentage point, and if the old rate was 3%, the new rate is 4%.
Okay.
But the actual percent increase, that's something entirely different. So if I were to say, what is the percent increase? the actual percent increase. So there's percentage symbol, increase.
Mm-hmm.
That is what we call that relative change. That's where you're taking your new value minus your reference value divided by your reference value. And you can do this with percentages. That is what? New value 4%, reference value 3%, divided by what? 3%. Now, that comes out to what you end up with this out of this mess. If I'm going to do this. If you do the calculation, you're going to end up with 1/3, which as a decimal is 0.3 repeating forever and ever and ever. So I'm going to say times 100%. So basically, if I just round to a whole number, that's 33%. And so it's just the verbiage. If they say, hey, we increased by 1 percentage point, then okay, we went from 3% to 4%. If I say the percent, I actually increased the percentage by 33%. So, which is, we're actually describing the same thing, just two different ways of describing it.
Okay.
All right. Okay, there. Okay. So let's talk about abuses of percentages to wrap things up. And here's a classic. And there's some homework that kind of gets back to this point. And recall that I said what changes those percentages you come up with in terms of reference values is, or your relative change or your relative difference is that reference value, the denominator of that fraction. So let's set this up. So let's say you're employed somewhere, and the business is struggling a little bit, and you agree to accept a temporary 10% pay cut. That's difficult to do, but let's say you did that. All right, so you're going to accept a 10% pay cut. You believe in this company. You want to help it out. Now, your employer promises a 10% pay raise after 6 months to make up for that pay cut. So, question. Will you get back to your original salary? What do you think the answer is here? Seems reasonable. Took a 10% pay cut. Your employer says he'll give you a 10% pay raise after 6 months. Will that get you back to where you started from? What's your gut?
No.
feeling? Yeah, probably not.
No.
All right. So let's look at the mathematics behind it. The answer is no. Yeah, you're not going to end up back where you started. Okay. So best way to see it is, let's just pick an arbitrary number, right? So let's say your original pay is $500. Now, so original pay is $500. 10% of $500. And remember, how do you figure that up? Turn what? 10% into a decimal, which would be 0.1, multiply it by 500. You're going to get 50. 10% of 500 is $50. So which means your new pay is $450. Everyone good with that?
Yes.
All right. Now, so he's going to increase your pay by 10%. That's what he said. But he's going to what? Increase 10% on this salary. Now, 10%. Yeah. 10% of 450 is $45. Which means after 6 months, you will be at $495, $5 less than where you started. So if someone says, yeah, I will, we're going to take a 10% pay cut, but in 6 months, I'll give you a 10% raise, be sure you say 10% of what? My original salary. So to get me back. So, yeah, that should do it. All right. Now, homework is 19 problems on this section. And it starts out with some definition type stuff, and we definitely covered, we talked about everything that's asked there. There's a few, does the statement make sense or does not make sense? I'm going to go ahead and give you a note. On number 6
Mhm.
of the homework, just like I did here, make up an arbitrary amount. To do the problem, make up some number. It actually is comparing two people and their salaries. And so this is just a hint. Make up salaries. And so you've got some numbers to use. If you have trouble with it, on Thursday, we'll certainly go over it. 6 usually always gets asked about. There's no show me an example on that one. So, but we will go over it if you have trouble with it on Thursday. Okay. Now, 8, 9, 10, 11, 12. So basically 8 through 12, just, this is like math 120E on that 3.2 that I assigned, just some basic percentage, how to go from a fraction to a decimal, and then from a decimal to a fraction, vice versa. 13 is looking at just simply some ratios of A to B. So recall, basically, if you're looking at a ratio, if you see find ratio of A to B, that is write a fraction A over B, and then you can turn that to a decimal and then move the decimal place twice to get a percentage. $14, kind of the same thing. 15 is, and these have shown me an example. Okay. So that will take care of that. So I'm going to go ahead. So I'm making this, putting the due date of the 16th, which is Thursday. Right, work past the due date. And I'm assigning 3.8. All right. Do you have any questions?
I don't think so.
Aiden, Casey, you guys good?
Yep, I'm good.
Okay, so let me go
I'm good.
ahead. I want to